Today I will take suggestions from you, the audience. Maybe we'll do some polls where if I have multiple suggestions for a problem, I will just ask you which problem I should do. Hello, Lakshai21. As always, I will focus on Twitch chat, because it's too difficult to handle both YouTube and Twitch at the same time. Hello, Ahmed. What's up? Was there some Division 2 contest recently? Today I will not do anything harder than Division 2. I see that there is educational round from 4 days ago. I can solve some of those problems. Also on YouTube we've hit 20,000 subscribers on this second channel for streams. That's a good achievement. What problems will I solve? I will get suggestions from you, just from the chat. If there are many suggestions, I will just do a poll. Can you solve this? Yeah, I will start taking a look at that. Also, if it's your first stream this week, no, I'm on Linux, but also it's a virtual machine. So I also I am on Windows at the same time, and in particular I can draw. I can draw over the screen if I want. Let me run this. Put something here. Right now, behind my face, there is something. I can click it, and I can draw x of I equal y of j. Like that. Might be useful. I can remove everything and hide it. Yes, Linux is good for programming. At least this is how I learned programming. Why don't I use VS Code? Why should I? I use Genie. So Twitch, give me suggestions for problems with a link with short description of what it is about, like why is it good, anything like that. Today's topic is easy Codeforces problem solving. This is also a good problem. This, that. Nice easy problem to start. Let's see the nice easy problem to start. It's this thing. Rounding. You've got n real numbers. I will first read and then decide if it's good enough. Adjust the numbers he's got. Round both sides. What difficulty? 1800. That's not an easy problem, is it? Not this. Contest. What do I want now? Standings. That's not an easy problem at all. Like, many people from the top solved it in 20+ minutes. It isn't easy. It isn't extremely difficult, but seems to be a difficult A problem. So some other suggestions, please. Maybe I will do this one. Nothing be above the 2000 level. Come on, easy problems. Division 2. I'm not defining easy like precisely. Or do you want me to solve this one? Maybe, actually, let's think about it. Oh yeah, here I have this bug where I cannot copy the link from virtual machine directly from Chrome. So we're doing this Jeff rounding. We take the input, we choose two numbers like 0.5 and 0.75. One of them we round up, the other we round down. Make the absolute value of the difference, some elements after percent, blah blah blah. So I think we need to consider two cases. One case when we want all numbers to become big, and one when we all of them to become small. But then it becomes very easy. There are some numbers with the part after the decimal. Both sample tests are quite bad, but here they will not be rounded at all. Then I will round this up and this down, but I would say the answer is 0.5. Sum of elements and the sum of elements. Oh, okay, because let's think and let's try this drawing over the screen. I'm not saying I will always do it, we'll see. Pen, yeah, it works. If we have like the integer parts, they don't matter. Let's imagine that I have 0.1, 0.4, 0.8 and 0.9. If I want to increase the sum of all elements, then if I want to increase the sum, then it's good to say you go up or does it really matter? You go down. Even for just two values. If you go down, and then we will get plus 0.9 and minus 0.4, so plus 0.5. If it's the other way, if you go, maybe then another color, if 0.1 goes down and this one goes up, we got plus 0.6 and minus 0.1. So anyway, we get this. What's going on? But if there are integers, then they are not affected at all, and I will choose integer with something. So if I take two values different than, like two non-integer values, it doesn't matter how I round them up and down, because, oh, this is a good way to put it. If we have, maybe another example, if we have, say, 15 Why did the size become smaller? 15.7 and say 6.6. Either we will get 16 plus 6 or we will get 15 plus 7. It's the same sum. This is equal to each other. So it's only important, like, the answer is trivial if no number in the input is integer. Please use dark theme or light theme across all windows, so you can... Codeforces looks very ugly with dark mode. We can try. But you know, everything here is experimentation. Let's say that I want to maximize stuff. So every integer like this one will be rounded down, so nothing happens. And then something small here I want to round up. I would guess that we need to count integers. Thanks to that, use some formula to say how many of non-integers I can just round up, because they are paired with integers, and the rest pairs up with each other. Also, I will read everything as integer. This. I guess let's multiply this by 2, because there are 2 n integers. Let's use round of x multiplied by 1000, then we will get really an integer. I can easily check if this is the number from the input is integer if and only if this is divisible by 1000. Also, integer part doesn't matter at all, like this 3. It doesn't affect the difference between final sum and initial sum. So let's just take this modulo 1000. Check if this works. Do I have wrong build commands? Yep. My debugging templates, they require this dlocal flag. I've just set up everything here in Linux, so some stuff might be wrong. Okay, this is 0, 500, 750, 0, 0, 0. Then second test, 383 and 896. And a lot of zeros. Am I reading wrong? This number is here. What's going on? Oh, this should be of size n. That's what confused me. Yeah, and then it's fine. I just didn't understand why there are so many zeros at the end. But I multiplied n by 2, and then anyway I created a of size twice n. Okay, now I think I have those non-integer parts of every number. I will consider two cases. No, not two cases. The sum of elements after performing as small as possible. So integers will go up, they will not be affected, and non-integers there will go down. In particular, it would be cool to put big values to put them down. Is that right? Let's say that there are 150. There is 150, 200, 400, 900, and one of them I can, maybe one more. One of them I can round as I want because it's paired up with integer, with a 0. I guess that I will just 900 round down, and the rest will be paired up. Or should I do something else? What exactly happens? After I say you go down and you go up, I will get plus 1000 minus 150 minus 200. Plus 1000 minus 400 minus 450. And for example, minus 900. So anyway, I get each of them is just subtracted from the answer. It didn't matter which one I rounded down. Okay. If a of I is 0, count zeros plus plus. Now this is the remaining n minus count zeros. Those are remaining ones. Though I need to pair up zeros with non-zeros. If there are 3 of one type and 5 of the other, there will be 3 pairs. Count zeros and non-zeros. Maybe I should remove count from a name. Otherwise it should be count non-zeros. This, count zeros. Okay, that many pairs. And not paired is that non-zeros minus pairs. For example, if there are 3 zeros, then that many non-zeros, let's say 7, then 3 the number of pairs is 3, it's minimum of count of zeros and non-zeros. Those will be paired up with each other, and those are not paired. They need to be paired up with each other. They will correspond to something like that in the sum. One goes up, the other goes down. Yep. Each of them will give us each such. Now they need to be, they are kind of non-zero pairs. How many pairs among those? Everything should be even. Sum is 1000 times new pairs minus the sum of everything. One, 2, 5, 0. I have 500 and 750. Am I solving this problem completely wrong? Oh, the absolute value of the difference. I minimize the final sum. Why are you not telling me? Make the absolute value of the difference between the sum of elements before and after as small as possible. We want to pair those things up in such a way that the sum before and after is almost the same. And instead I minimized or maximized the final sum. So the value of this is maximum possible difference. I would print 1.250. In the second I would print 1.279. Sadly, this is not just about the integer part. If the test is more complicated, I will get this value completely wrong. Hey, just like Snapdragon says in the chat, this is like a knapsack. Ignore the code for now. Let's think again. Yeah, those don't matter. Those do. I have a choice between plus 500 and minus 500. Maybe quadratic DP, where my idea for now is DP of position that I already considered some prefix, and then no, but I don't minimize or maximize. Nope. I see some too slow DP. Let's make real drawings. I can't do Control Z. Maybe it's because I see. Some other program, I think, captured Control Z. Yeah, now it works. So when we have something dot 200, say everything is 0.2.xyz. We also have 0.555, 0.600, and so on. I might use in complexity the fact that these are just like 3 digits after the decimal. Can we minimize absolute difference using DP? I'm going to do it because it looks like knapsack. It looks very similar to a problem where you're given a bunch of values, like let's say -7, -3, 1, 4, 8, and 20. And you want to find the sum of values giving the set of values with the sum equal to 0. Is it possible here? I don't even know. -3, 10, I don't think so. But if there was additionally a 2 or another one, you could say -7 -3 plus what am I doing? Plus 8 plus 2 is 0. This problem can be solved with some DP, assuming that values are small. Here it's the same, values are small. I would say that the solution will be cubic, 1000 cubic, and that's too much. Because if there are a lot of values, then in DP we ask a question after we decide about those values, what is important so far? And here it's important, it will be DP of this position, let's say position I, then how many numbers we rounded up, it means the remaining values we rounded down, and just what is the current value, the current sum. This can be up to n, this can be up to n, and this is up to like n times 1000. So the number of states seems to be n cubic multiplied by 1000. I don't need to find smallest and largest value in knapsack. I need to find closest to 0. This sum can be negative. Because if this I round up, I will get plus 800. If this I round down, I will get minus 555. Knapsack is multiply all values by 1000, calculate the possible remainders of subset sum. Why is it enough to here store like 1000? Like remainder modulo 1000. If I get information that I can round those values in such a way that the ending part will be dot 0, 0, 1, 0, does it mean that I can achieve 0 here? I'm reading what Des Craze says in the chat, but I don't agree. Oh, but wait a second. After everything will be integer. This will be 1 or this will be 0. So I need to compute the sum of values in the input. Let's say that sum of values becomes 14.321 and then it would be best to get 14. Is that always possible? Is it enough to take the sum of values from the input, let's say that this is it, and to say that I'm going to achieve exactly 14 in that case? Multiple times I have a choice between rounding up or down. So I can say I think we will not need knapsack. Okay. Here's what I'm going to do. I have some values. Something. I will compute their sum. Let's say that sum is equal 14.321. Now, I know that each of them can be rounded down or up. Maybe here the second value is just integer, 5.000. Then I just say it will be 5. Let's take first all the lower possibility for every value, and then we will get some sum. We'll say, let's say the current possible sum is, this was S0, the initial sum. The current big sum is, say, 12, because the sum of those lower possibilities for everything is 12. And now I want to raise it up to 14 or 15, as close as I can. And the thing is, I need to choose the upper value exactly n over 2 times. And here it doesn't matter. So I have some number of integers. Let's say there are 7 integers in the input and 3 real values, non-integers I mean. Then it means at most 3 times I need to do +1, And I can even do it 0 times, because 5 times I need to do the bigger value, but I can do it with those. So if this is the case, then starting from this, if x is 12, if I round everything down, I can achieve everything in interval 12, 15. Because 3 times I can increase by +1 compared to the lower possibility to choose the upper one. If, for example, I have 3 integers and 7 real values, by real I mean non-integers, then I can use at most 3 times this +1 fakely on int. So at least 2 of them really need to be rounded up. So I can get any value from 14 to 17, assuming that x was initially 12. Because the best I can do to get a small value is 3 times round integer up, and 2 times round some real value up, and then I will get 14. Or I can use all 5 tokens to increase real values from rounding down to rounding up, and then I will get 17. I will answer to this. Oh, this is full screen. This is why I cannot see it. Those comments by Des Craze. Calculate subs. I understand what you want to do. You want to do an AppSack over those real parts, but if you compute that, the final real part can be, for example, 985. Then still, what do you know about possible integer part? You would need a proof that every integer part is possible there. I provided a proof there. I claim that the final sum, it is some interval of values. But we don't do any DP here, because rounding either will change 2.730 to 2.0 or 3.0. So this real part, it affects the first sum, but it doesn't affect the final sum. The possible situation is, for example, that the sum of numbers in the input is 14.321, and at the end we will get 12 or 13 or 14 or 15. You can take k ceilings and increase the answer by k. And you know that k is greater than sum of decimal parts. Well, if everything is 0.999, answering to your comment, if everything is something 0.999, then rounding half the numbers up, the sum of those ones isn't greater than the sum of decimal parts. This solution implies, like my observations, they imply that range of possible values is an interval of some integers. Okay, so new solution is count integers, also compute the sum of stuff in the input. Choose the smallest. Can I construct a case? Let's get back to drawings. Can I construct such a case that the sum of values in the input is, for example, this, but I cannot get 14. I cannot at the end get 14. Is it possible? Let's try to construct such a case. Oh, even easier. Let's say 0.01. Let's say that this is the input. Then the initial sum is 0.04. Now I can round everything down and I will get x equal to 0, but then two of them I need to increase by +1, and actually exactly two of them, there is no integer, so the real interval of values I can get is 2, 2. After I make my decisions, the sum of values will be in this interval, and I need to say that the difference is between the initial value and the final value is 1.96. This shows that integer parts are important too. It's not just about focusing on the decimal part. Okay. If you start from the 12 point something with only floors and you want to get this, replace 2 floors with ceilings. Yeah, but you cannot get non-integers. That's first of all. Second, replace 2 floors with ceilings. You can replace limited number of floors with ceilings. And the number of those possible +1s is decided by the number of integers and the number of real values in the input, like that. Also, I see some other example in the chat where this cannot be done. Let's consider one more case. 0.01, this several times. This one more, and also a 3. Then the initial sum as 0 is equal 3.05. X is equal 3, that's if I do nothing. And the number of real values is 5, the number of integers is 1. I can increase all of those by 3, or I can increase just those two by 1, and this one change floor to ceiling waste on this integer number, so it isn't affected. So I can add +2 or I can add +3. This means that the interval I will get is from 5 to 6, because it's x +2 or +3. And now the answer is the difference between the initial sum and the closer of those two values. I mean, the closest integer value in this interval. And now we can code. Okay. I'm not surprised that people took 20 minutes on that, even though the solution is very easy. And the final solution. It was wrong to think about DP and knapsack. What do? I just count integers and non-integers, or just let's count integers. Let's also count this initial sum. And they want to do stuff on doubles. Let's do it on doubles. The sum will be of magnitude, let's see, 2000 times this times 3 more digits after the decimal. Well, this is around 1 billion or something like that. The double can handle values up to this. So as long as you don't exceed this value, you can use double and precision will be good enough. Double floored. This is the X from my drawings. Okay. 2 times n times create some value x, read it as a double. Now, what can I do here? Init sum plus equal x. Float sum plus equal. Let's make an if, because I need to count integers. If x minus L round of x smaller equal epsilon. If it's close enough to its rounding, then it's integer. Else take the floor. I don't want to take floor if it's integer, because I'm just afraid that, you know, number 17 will be treated as 16 point a lot of 9s, and then it will be rounded down to 16. That's dangerous. No, double can hold value as big as, let's say, 10 to 18 or something like that. If you type double x is equal this thing, it will store it, but it will cut some last digits. Let's actually print it. I want to print it with print, because then I know what the format will be. Or just let's remove everything after that. You can see what will happen now. Point 0. Okay. Run A. Let's see. It's 1, 2, 4, 3, 8, 5, 2, 3, 8. And I bet in a moment we'll get precision errors. 5, 9, 5, 9, 8, 2, yep, up to here. That many digits were fine. That's about right. That many. We got some trick or treating. Yeah, just assume always that numbers up to this value are fine. And then you can precisely treat this as an integer. This double handles this relative precision, 10 to minus 15. Assuming you don't do a lot of operations to modify that. Or you don't do complicated stuff like power. Yeah, then this. Now some formula. Real values, non-integers, is twice n minus integers. Oh, how many? Oh, float sum is int. Yeah, then. Just add integer. And now the formulas I showed you in a drawing. Like if we have that many ints, that many reals, then what do we do? How many at least plus ones we can do? Can we do 0 plus ones? We can do it only if integers can soak all the n operations, n plus ones. Like we have some number of integers, some number of real values, and we need to distribute n over 2 operations between them, and we count how many of them were on real values, because only they get plus 1. At least will be, like in this case it would be 2. It will be n minus integers, I believe. they can take a hit that many times. Other than that, I need to use +1s. At most, I think that each of real value can take +1, but I only have n operations. So now everything between floored sum plus at least, low is floored sum plus at least, high is this, all integers between them are good, and I want to get something close to that. Let's say infinity. Okay, let's not do that. Init sum. This is brute force from low to high. Ans is minimum of itself and the difference between x and the init sum. Will you take a look at lunchtime problems? Not today. I believe that's right for sample tests. Now, is this good complexity, this for loop? Yes, the values are, this is of magnitude 10 million. This should be fine. I can later improve this. That was not easy for sure. Let's improve that final thing. If I know that all integers in this range are possible and I want to get something close to that, then what do? If init sum is smaller than low, maybe smaller equal would also be fine, answer is low minus init sum. If I want to get something close to 5 and my range is 7, 10, then 7 is the best. If init sum is bigger than my range, and else init sum is inside my range, then I'm interested in the ceiling of init sum and the floor of init sum. Like if init sum is now 17.600, I will say 0.400. X is answer is minimum of init sum minus floor and ceiling this should work. Sample test will not tell me a lot. I just added three cases. So 2 samples will not check 3 cases. Yeah. It's a bit faster, likely because of this final part. Now my complexity is just linear O of n. And previously it was quadratic. It was n multiplied by 10,000. Done. We're done with Jeff and rounding. It was surprisingly nice problem. That I wonder what the editorial says. Oh, I thought that this is the editorial, looking for a few cases. Initially, we should remember the number of integers. We will round down all numbers and count the sum. Now we change the sum, rounding up some numbers. Consider a couple. Okay, they consider 4 possible cases of matching int with non-int, and so on. From some moment, I started thinking about this problem as we don't pair up values. Instead, we just say that n of them must be rounded up. So I round everything down, and I need n times do the operation of basically +1, but integers are resistant to that. N times, I choose n elements, and for each of them, if you were real at the beginning, then you get +1, otherwise you get +0. I bet that those cases are related to my formulas as well. Check to see if you can get such numbers. Whatever. Let's do another problem. The pink comments, oh god. Is it bad? The goal was to make it more visible. I want to write a lot of comments when explaining stuff, when explaining any code. So I changed this from gray to pink. Some team has it pink already. Somebody suggested that it should be light red. I don't know. I'm experimenting. You're looking for suggestions. Please don't repeat stuff. And when you're suggesting something, write a few words of explanation of why is it good. Yeah. So to those who watch on YouTube, for live chat, go to Twitch. Gray comments were better. Why? But aren't these easier to read? Or maybe too distracting? And indeed, don't post the same link twice. Greedy plus DP, it's educational 1900. Let's do one very easy problem. What about that? I wanted to start easy, and this one took me already. It's 50 minutes from the start of the stream. Do you have something of difficulty around, I don't know, 1200? Purple comments contrast is high. Is it too high? This one is not bad, 1700. Nobody wants me to solve 1200. Okay. I will check out some 1700 GCD table. Either this, and really, I don't like this dark reader look in Codeforces. Either this problem, given all numbers of the GCD, some constructive problem, I guess. And this is, what, 1700? Yeah. Constructive problem related to GCD, or I will grab another suggestion. Scheduling problem, shurikens. One of these two. And let's do a poll. How is the website called? Stropple. So GCD table, this is constructive or shurikens. Here you go. All right, I cannot copy paste directly from Chrome. Also, cool thing I did today, I started testing the division for contest by Slavic and Sense, and for 1 hour I taught them how to use Polygon and how to create nice tests for an easy problem. And I have that 1 hour recording. After they publish their contest, I will publish on YouTube some videos about preparing problems in Polygon and about how to test. Because there's always so many testers in Codeforces rounds, but none of them, or almost none of them, does something like almost none of them does something other than solving a problem. Just use poll for Twitch poll. but I also pasted the link to YouTube, guys. And in Twitch, the poll didn't work for me in the past. Some error occurred. I was using Polygon today. That will be really helpful. There's so much to do: validators, trackers, and so on. And Polygon is something where you need to click a lot, so it would help to have some video tutorials. Shurikens is boring. Shurikens was covered by so many people already. Okay, that's some argument too. Let's see the results. GCD table. Give you the link. Done. There is a sequence A. Didn't I solve this problem in the past though? No, I didn't. There is a sequence A, and you're given GCD between every pair of elements. Elements are given in arbitrary order. Okay, so it's not an array. It's like it's like if somebody did this for every element X, for every element Y, vector pushback GCD of XY, and shuffle. This is pseudocode, it will not compile. We need to detect, we need to find any input array A for that algorithm to produce exactly this sequence. Most likely we will need to count the biggest element. In particular, there are pairs like the number with itself. This will be useful. If I sort the sequence A, at least if I imagine the sequence being sorted, then in particular every element can be paired up with itself. So in my sequence of GCDs, not only there will be some GCDs between them, like 2 and 6 will produce us 2, 3 and 5 will produce us 1, and so on, but in particular I will also get 2, I will also get 3, 5 and 6. The result of GCD of an element and itself. So the biggest value in this long sequence of GCDs of pairs must be equal to that. Maybe we will go from biggest values then. What about second biggest value? Could I just took this input and say the biggest value here 6, it's one of those in the input in sequence A. Then the next one here is 4, also let's take it. Next one is 3, let's take it. Next one is 3. But as I create this every next biggest value, I know that pairs of them produce some GCDs. The logic will be, okay, I see that 6 is the biggest value in this sequence. Then I see that 4 is the biggest, but also, this is one of those numbers I need to print, but also 6 and 4, they have GCD, it's 2. Because I detected that 6 and 4 should be, values to print, I also know that their GCD is there in the input. Okay, what's the next biggest value? 3. But I know that also 6 and 4 are there, so I take GCD of 6 and 3, it's 3. I take GCD of 3 and 4, it's 1. This would be a sequence here, long sequence of GCDs, if the array A was 6, 4, and 3. I know those must be there, and if I look at this sequence I'm given, the sequence of GCDs, I guess if I erase those elements, then I just need to take the biggest next value. Because there is some also value x I'm looking for. And there are some other GCDs. GCDs must be smaller than x. So x is the biggest of remaining values. So the logic is, do I need a multiset? Yeah, let's use a multiset. There can be repeated values. I need to be able to remove 1. Divide and conquer on prime factors. That's overcomplicated. Maybe it would make sense in harder problem. Oh, you're right, Gupta. For 6, 4 there will be two times. Because we take GCD of AB and BA. So each of those produced GCDs occurs twice. Let's read what is there. Put everything from the input into a multiset. What then? Do I print? I will just immediately print. Oh, I need to store that. Print. Repeat n times. Take the biggest value from multiset. The biggest element. Now iterate over stuff in print and say that as erase GCD of old big, and do it actually twice, because we also take the other way around. Print push back big. Also as erase. Oh, this shouldn't be on multiset. This erases all occurrences of a value. I want to erase one occurrence. I will create a lambda function for that. Let's call it just erase. I will run it here. This comes here because I found the biggest remaining element is 4, so let's remove 4 from that multiset. Because it also 4 is GCD of 4 and itself. I could say that this is actually GCD of big and big. Yep, and I can, why not just print it? Looks fine. Sometimes the copy button doesn't work for me, and instead it sends me to the top of the page. 1, good. Please explain the erase function once again. It erases one occurrence of a number in a multiset. Why Codeforces doesn't know that I'm solving this problem? Or maybe because of question mark in the link? Strange. Okay, this is 583C. 583C. Okay, good. If I got wrong answer on test 1, I would expect that I'm submitting to wrong problem. 140. Do you want me to explain some example what happens here, or do we move on? You had problems at link. You can click on code test link. Okay, so I could if I do it here, it doesn't work. What I can do is go there to a contest, open the problem. Oh, and it is a different link. While I'm in a contest in this problem, I can hit submit code and it knows. It still doesn't know a problem. But the theory is if you choose something from problem set, open it here. The link contains a word problem set. If you hit submit, here it knew what to do. How is this possible? Okay, explain one example. Let's just simulate what happens here. Why can't I modify the font? I can. I don't know why it got strange background formatting, but you know, whatever. I put all of that in a multiset, so it becomes sorted, but whatever. And I take the biggest element. The biggest element is 6, and I erase it. Then I take the next biggest element, it's 4 in this array. I erase it, but also no. If 6, 4 and something, if this is the array A from which somebody started and then created GCDs, then some GCDs were 6 because it paired 6 with itself, then same with 4, but also A2, GCD of this and that. So I remove one occurrence of 2 there, and I say the remaining values in my array, in my multiset, those are GCDs of those unknown elements with themselves, but also with 6 and 4. I already removed GCDs of 6 with itself, 6 and 4 with itself. And I'm left, those GCDs are left. So numbers 2, 1, 3, and so on are GCDs of red pairs I marked. Okay, now, yeah, so actually I should have left the red stuff. Oh, it is here. Among them, I see that the biggest value is 3. Among remaining values in this multiset, the biggest value is 3. And it's not that, for example, this connection can be the biggest, the only biggest value, like this, the yellow thing. Because this GCD of 6 and whatever mysterious element is here, so there is some unknown x and unknown y, GCD of x and 6 cannot be bigger than GCD of x and x. So if this sequence is 6, 4 something is sorted decreasingly, then this yellow thing is the biggest GCD, GCD of x with itself. Among all the red and yellow edges, this yellow one has the biggest GCD. So this is why we say that x becomes 3 apparently. Let's remove all those edges. Okay, now I know that x apparently is 3. And now those connections I need to remove from the multiset. 3 and 6 is 3, 3 and 4 is 1, 3 and 3 is 3. Here I can write that down, what I've just said. 3, 1, 3. And finally, y. Oh, and each of those numbers should be duplicated. Like when I took pair 6 and 4, it gave me GCD 2, but it should be double because I also take GCD of 4 and 6, not only 6 and 4. Similarly, it's 1 and 1, 3 and 3. So I should remove some more elements. 3 is repeated, 1 is repeated, 2 is repeated. Okay, 1, 2, 3, 4, 5, 6, 7. That's right. Now, if we know that y taken with each of those values gives those GCDs, then I know that y is 2 because that's the biggest value. So I say, hey, y, you are equal to 2. And yeah, also remove GCD of 2 and 6 and 2. Remove GCD on 2 and 4 and 4 and 2. And remove this GCD times 2 also, and GCD of 2 with 2. At the end, we could make an assert that our multiset is empty. Done. We can, I bet that we can here say assert, just maybe we add assert. Size is s.size. This will be 0. See, it is 0. It became empty. Let's go to another problem. Another GCD problem, 1600 points, maybe. Twist in the classical problem. Beautiful array. So this is possible. Let's get one more suggestion. I'm just reading Twitch chat. Sorry, YouTube. Graph problems 1900. Let's just between those two. Oh, that's not. I'm trying sometimes to put a page from a different system. What I'm holding is on Windows. What you see in the background is Linux. It doesn't see each other. I cannot put it there. But a link I can copy. Let's do one of those. Okay, I will try this time just a poll on Twitch. It will be easier for me. Okay, how to do it? Am I logged in? I'm not. Gave me gave me confirmation passwords to my email. How is it called? Two-factor authentication, I believe. Here, you're saying that I can do here poll. Vote. There is no poll command. But I also remember that I once did this. Does it have to be Codeforces problem? Yes, I would prefer so. Then again, straw poll. Beautiful array is what? Okay. Something. Beautiful array sequences or cow and fields is a graph, and it is a harder problem. All right, I cannot copy a link. I need to fix that. Very annoying. Here you go. Here you go. I have some questions for you. Will you do any discussion YouTube video? I don't get your question, but you can join the Discord server. So yeah, if you're enjoying my streams, join the server. Maybe you don't have the poll command enabled. I don't know how I would disable or enable that. But what I know is that in dashboard in Twitch, there is a possibility to create a poll with some UI, and it doesn't work. Once I'm done doing it, it gives me an error. I wrote to Twitch support, and they just copy-pasted some email to me like, please check different browser, blah, blah, blah. Then I answered, they copy-pasted the same email, and that's it. I didn't hear from them ever since. Your Genie looks upgraded. Not really. It's all the same, but just with a pink comment instead of gray. And this annoying thing, I don't like this red close button. If anybody knows how to modify it to gray, let me know. If I open Genie on Windows, it is slightly different, like that. See? This is the Windows version. Once I save this, this becomes black, but still the difference is just in the close button. Let's solve the less voted one. That's an interesting approach. Graph, a harder problem. Cow and fields. Okay, let's do cow and fields. Twitch mods are mostly Sims. Yeah, but not Twitch mods. I don't think they are in Twitch customer support. Somebody else answers emails. Stropple is coming in Twitch chat, so this is even better. I don't know what you're talking about. You mean that Stropple will get integrated in Twitch chat? Problem. You can grab a link. Another collab with Tourist. If you know him, you can tell him that you can collab with me. He can collab with me. Okay, cow and fields. You're given a graph, you need to, there are some fields, some vertices are special, you need to put one more road between special vertices in order to maximize the final shortest path between 1 and n. For example, if black here shows the initial graph and red vertices are special, if you connect 1 with 3 with a new special road, it will shorten the path between 1 and 5 from length 3 to 2. But it's allowed to just again use this edge. Is this graph connected? One can reach any field from every other field. Yes, the graph is connected. Here we don't have any choice. There is some graph. Let's say that this is vertex 1. Let's say that this is vertex n. Some vertices are red. And I need to put one extra edge between two red vertices. I have here three choices. This, or that. I don't want to have a short path between vertex 1 and vertex n. This edge is bad because now it allows us to travel shorter between 1 and n. How can I consider a single edge in constant time? It will not allow me to solve the full problem, but let's try to first solve the problem in complexity k square n plus k square times 1. I will consider each of those red possible connections. K is the number of red vertices. How can I say quickly what's the length after this? I would need to pre-compute lengths from vertex 1 to every other vertex, and so on. And also lengths from n to every other vertex. And so on and so on. Now, when connecting two vertices, either I have the same shortest path, or I have some path from 1 to one of those vertices, I see that its length, and then from this other one to vertex n. If this graph was bigger, 1 was there, n was here, and I connected those two vertices because they are special. This is the special edge, and I know that from 1 there is this path of length 5 to this, from this one to n there is something of length 3, then I know that new shortest path is of length 9, or whatever was previously there. I can iterate over all reds, or possible red connections, pairs of red cities. Okay, and now I need to do it faster, and likely this brute force will help me. The fact that I solved it with such a quite fast brute force, how to in constant time check every candidate, it will allow me, I believe, to solve the full problem faster than k-square. Because now I can run those two BFSs. I can compute those blue distances from 1 to everything else, then in yellow distances from n to everything else. And now each vertex has two values, the blue distance and the yellow distance. And I want to maximize the minimum between, let's call it, let's say x of I plus y of j plus 1, comma, the other way around, x of j plus y of I plus 1. Like that. This is just like here I said that if it's 5 and 3, then the total length is 5 plus 3 plus 1, because the special edge is also counted. And I assume that x says the distance to vertex 1. This will be I, this will be j. Over all pairs I comma j. This just says that either from vertex 1 I will go to I, then special edge to j, then special edge to n, or 1 to j to I to n, where the middle part is the special edge. You don't need to put suggestions right now, because I'm solving another problem. How the shortest path will increase after adding an edge? It will not increase. I just don't want it to decrease. The problem is equivalent to saying after adding edge, I don't want the new shortest path containing this edge to be short. That's it. This is why I maximize this shortest path going through this edge. You can iterate over I and find the best j. Maybe. Okay, I want to maximize this. Let's look at that. I can transform this a little bit. Indeed, I can iterate over I. Does it make sense to imagine those as points in 2 dimensions? I don't think so. Sometimes visualization helps. I can transform this by subtracting yi. Let's see what happens after I know I. Then I want to maximize the minimum of, let's say, 7 plus y of j, comma 4 plus x of j. Can I do this after some pre-processing for all those pairs j? Maybe here visualization will help. Actually, it's a 3D visualization. If I say that value of j is equal this, then we'll have some 3-dimensional shape. But if I put those points xy, 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 then if x is equal 3 and y is equal 0, they both give me some value. Y is equal 0, x is equal 3. And now if I decrease one of them, it will be the same value. All the points in this area would give me the same value. Then all the points in this area will give me the same value. All the points in this area will give me the same value, and so on and so on. Am I right? Example, x equal to 0 and y equal to 3 will give me 10, so it's the same with 6 equal to 0. Yeah, that's right. Now, can I, given points in 2 dimensions, can I create such a data structure that then I will be able to answer query, given this strange direction thing, find the first moment when there is a point here. We can do some kind of segment tree. Or persistent segment tree, but maybe I will be able to do it offline. Well, being here, assuming that I have a sweep line going from left to right, have a sweep line going to the right, so I already built some data structure like a segment tree over those points. I'm able to say just basically, is there any point here below? But if I'm just asking for some point, is there any point below, that means binary search. Binary search often just asks, is there anything like that? If yes, find a better answer. With binary search, I will just need to ask, is there any such point? Like, I'm asking if I need to maximize that. Can I get this to be greater or equal 10? This is a question I need to answer. Minimum of those. So it will be just, is there anything in this area? But that's very easy. I just need the rightmost and topmost point. No, wait. I think my shape is wrong. Care about the minimum of those two. So 3, 0 is here. Okay, and now if I increase one and if I increase the other, then it doesn't matter. The shapes should have been like this. Yep. And then my question, can this be bigger than 10? Because I want to maximize it, is just, is there any point in such an area? Is there any point here? And that's, for example, persistent segment tree. And because I once did the sweep line from right to left, and going from the right, I keep some segment tree with points, all the points occurring already on the right. And while being here, oh, not even that. I just need to say, is there any point above? Not how many of them there are. So just, if I write down the sequence of y coordinates, let's say that y coordinate of this point is 4, of this one is 3. If I write this down below, this is 5, this is, let's say, 4, 2, and so on and so on. The binary search just asks me if in some suffix, like this, is there any value bigger than something. This will tell me if there is any point in this area. I will do binary search over the answer. And then, do I need binary search here? I guess. So sort points by x, so from left to right. Then with binary search, find about what suffix we're asking, and just ask suffix maximum. What's the maximum y in that suffix? And then we'll find maybe one of those 3 points, if and there is any such point. So in other words, in this right part of the drawing, we ask for the highest point, topmost point. It would be in this case here. If it's above this line, yes, there is a point in this area, so the answer greater or equal 10 is possible. Persistent segment tree. Persistent segment tree is an advanced structure, but not crazy hard. It can be avoided though, most of the time, because almost always you can do things offline. You can gather queries. Maybe not here, I'm not sure yet. But yeah, it turned out that we can just do... This is an example of a problem where for a moment I thought persistent segment tree, but at the end it turns out just once sort the points from left to right, and then we'll keep asking in some suffix whether there, like what's the maximum in the suffix. You can do segment tree or even just suffix maximum to know, oh, in the suffix maximum is equal 6. Then we compare it with this thing. The coordinate of those two lines, of this point and those two lines, they come from looking at this equation. Let's remember that we do this for every I. And for I, xi gets, in the formula, xi gets replaced with something, like xi plus 1. This exactly I got, assuming that the point I is equal 6,9. No, I didn't think about it, but well, nice. And then this, what I will highlight here, turns xi plus 1 becomes 7, and yi plus 1 becomes 10. Oh no, this is 4, so this should have been 3. If point I is 6, 3, then this formula, xi plus 1 plus yj, and this thing, it becomes what I wrote what I wrote here. Yeah. So my Linux got to sleep mode, because I was drawing in Windows. I will first take a look at Editorial to see if they did the same thing. Is it current friend? Current fields. Let's use BFS to find the distance from 1 and n. They also denoted stuff by xi and yi. We want to choose two fields and maximize the minimum of this. That's exactly my formula, just I had also plus 1, but plus 1 you can put outside of brackets. Without loss of generality. Okay, that's smart. So we care about minimum of those two, and they say let's consider cases where this is smaller. But you care about which value is smaller. If you want to say, okay, let's see, oh, this is 5, so apparently the minimum will be 5 because I said so. No, like, you only want to consider those cases. You can consider cases where this is true, but you will need to worry about it. So I think they transformed it like that. Yes, they did. It makes sense. When you have any inequality with one value depending on A, one depending on B, then A, then B, it's very common that you group them. And indeed, here on one side now we have stuff depending on A, on the other depending on B. This way we can introduce some new variable. Like, oh, many times I will care about XA minus YA. Let's introduce ZA equal to the difference. Or just let's sort by x minus y. Let's grab my drawing and understand what they did. So we have this. Now we say that let's focus on cases where the first value is smaller. So the left part smaller equal the right part, and I will move i's to the left part. Xi minus yi. No, the plus 1 on both sides gets reduced. Smaller equal xj minus yj. Okay, among those pairs ij, I want to maximize this. What? Yes, exactly that. So visually, x minus y, this is everything along this line has the same x minus y, right? Maybe if I increase this by 1, yeah, exactly. So I sort, like if I is on somewhere on this line, then j can be somewhere on this line. Okay. Then I have this sweep line, and it travels in this direction. It goes like that. This is equivalent to sorting by x minus y. And now whenever I see here some point, I consider this to be point I. Then I see for every point j here already processed, this inequality will be true. And then I want to maximize this, because I know that this is smaller of the two parts of this term. I want xi, I know xi because I'm currently at point I, plus y of j, and I want this to be big. So we just ask, what's the biggest y in this area so far? So as we go with my sweep line, with yellow direction, I just store int max j so far. Max j so far. No, max y so far. And I say, okay, possible answer is x of I plus this, plus 1. And you know, in code you will not have really geometry. Just this explains to you what this is, visual explanation of what the editorial did. My solution was more complicated. Yeah, it was far more complicated. This one is better. But I'm familiar with this trick where we have minimum of 2 values. We often care, okay, let's focus on cases where one of them is smaller, because it's hard to focus on both at the same time. How maximizing left side will help us? Because for every pair ij, this is length of the shortest path, more or less. Okay? I want this to be big. If somebody told you that, hey, maximize the value of minimum of x comma a plus b, let's say this, you need to maximize this, then you care about 2 cases. Among possibilities where x is greater or equal a plus b, then you want to maximize x, because you know, if this is 7, this is 10, then 7 is a possible answer. Also, in cases where this is true, you want to maximize a plus b. And let's say this maximum of x turned out to be 7 in those cases, maximum of a plus b 8. Among cases where this is smaller or equal than that, so you say that the answer is 8. Take maximum of those 2 values. I also think that intuitively it's easier to understand what I did. I explained my thought process. Do I in contest just go about solving with harder solution, or will you spend some time thinking if you can come up with simpler solution? I mean, if problem is very easy, I will immediately come up with a solution to the full problem. If something is very difficult, then it does help to go through brute force first. Or maybe even but it's very common that brute force is trivial, like n square is trivial and we need to come up with n log n. Then I don't really write down the brute force. I know what it is. But here, during a contest, I would first do what I told you at the very beginning. How to consider every edge in constant time. Please switch to Vim. Or what about this? You switch to Genie. How long is the stream? Hour 45. One more problem, I guess. Deal? Good. Start a YouTube channel so that I would be sure that you're using Genie. I'm taking suggestions from the chat. Give me a link and some short information about the problem. I'm not going to implement this one. It won't be interesting. You can read this code. We do BFS. We sort with proper data. Okay, they create pairs. What is us? Is this something special or just a vector? No, this is some vector and it's treated as keyword in C++. This is why it's like special here font. They have pairs difference x minus y, comma x or something. They sort by that, so they sort by the difference x minus y. This is equivalent to the sweep line. They store maximum y so far for every item. This, I think, is index. Yes, it is index. And they consider max plus dist. And at the end, they add 1. Oh, it's exactly what they described. If you want to see implementation, just later do that. Data structure sorting, maybe that. Yakuza, don't repeat. Like, oh, somebody asked me this in past days. One of my students asked me that. Okay, so perform easily is one possibility. It's some recent problem. What else? Inclusion, exclusion, but is it difficult? Yeah, 2400, not today. If you want to see me solving hard problems, go watch me on Tuesday. Okay, now Treasure Island, we can also do this. It has flow in tags. Maybe a harder one. This is, let's say, related to 2 pointers or something like that, some sequence related problem. And something else. Right, let's vote between those two. Students, do you take online classes? I have a few, but just a few, students for private lessons, but I don't accept new students. Let's do voting between these two, and this will be the last problem of the day. Stropple. This is, let's say, I will call it sequences again. Or Treasure Island. Read or flow. Waiting for results. If you have any ideas for how this stream should look like, by the way, Is it fine that just in cycle I take some suggestions from the chat, I choose two problems that are fine for me in terms of difficulty, let's say, in topics, and I ask you with poll, maybe this should be something else. On Thursdays I cover coding interview problems, and for the past month I'm experimenting with a homework there, where I also choose two homework problems. I'm just seeing how it works. For the next Thursday, I also said that I will review some codes. Maybe it will work, maybe not. If it does, then I also can do the same on Saturdays. I will not do that on Tuesdays. Tuesday is just hard up solving. I don't plan that too much. Could have a Discord channel where some propose problems and others vote. But you want this to happen during a stream or between streams? I have a Discord channel already. Oh, you mean a separate channel, not a server. Between? So I think there should be then two channels. One will be where people put propositions. There cannot be a lot of spam or discussion. There is some Discord bot that can take things from one channel or just general programming, whatever. You can use a command to propose a problem. Then this post with proposal gets taken, copied to another channel, and there you can vote. I can also pre-pick like 10 problems and you can vote on them. This is what? Well, this is built in Twitch? How does it work? Does everybody see this? Awesome, that's very convenient, but I didn't know that. Wait, I will try to click my link. To do it. Wait a second. I get redirected. Are you on PC or mobile? Let's see the results. I like the idea of voting between streams, but it removes some interaction during the stream. Okay, perform easily slightly won. 31 to 23. So let's do it. Oh, I have it on the side. This is the last problem of the day. I will do this, I think. We will do some voting in the Discord. Maybe at least for like 2-3 problems. Let's see. Perform easily. I need to give you a link. All right. If somebody knows how to fix the fact that I cannot copy rich text between virtual machine and my computer, or actually it's just one direction, then tell me. Blah, blah, blah. The drawing is great here. As I said, I already know this problem. I didn't implement it, but I know some of it. And drawing is just great. Still, it doesn't beat the drawing by this guy. It's so nice that I want to try to find it. The one with worms. Maybe somebody can find it. Did he do any Codeforces round? I don't think so. Maybe one of those. Does anybody remember the problem with where drawing was in Paint? It was worms underground. That was the best drawing ever created in Codeforces. And the guitar has 6 strings and frets numbered from 1, fretting the fret number J, and the 5th string produces this note. I will start just drawing this. Okay, that works. Yeah, let's say that A1 is 7. Then this string or fret. I don't know these words in English, so it's hard to understand. Fret, string. String number 1, if it has strength 7, it means it can produce note 8, 9, 10, and so on till infinity. It can do 1 million, it's just everything. We need to do some notes. Maybe, for example, in the input there is 10, and then it means we need to use this. There is also second one with some strength, 15. Then it can do 16, 17, and so on till infinity, no limits, and so on. And eventually A6 is here. Maybe it's 9, so we can do 10, 11, and so on. The easiness of performance depends on the difference between maximal and the minimal indices of used frets. So if you use this thing here, an 8, this you use fret number 1. This is number 2. So just we care about the index. There are several sequences. This one, and the 6th one. There are 6 sequences of values x, x plus 1, and so on. And if you use something, you care about its index. Maybe you use 10, then you care about its index 3. You use this 10, you care about its index 1. Then you gather all those indices and you care about the difference between maximal and minimal index used. Determine the minimum possible difference. Whenever you need to determine minimum possible difference, also binary search might be viable. I'm not saying it will be, just maybe. It's often DP or binary search. Blah blah blah. Limits are big. N is the number of nodes given. So the input will be. Where am I? This. The input will be 6 values like 7, 15, 9, and so on. Those starting strengths. They define infinite sequences. And also we're given information about what is needed, like 10, 17, 50, and 12. It means that each of those values you need to choose them from our 6 yellow sequences. Okay, I hope the problem is now clear. What do we do? One idea is to indeed use binary search and then move with some kind of sliding window. Because if I want to check that maybe answer possibly is 3, and or maybe lower, maybe higher. Then I wonder if maybe by using only first 3 indices from every yellow sequence, I can get all those given in the input. If this doesn't work, I move my sliding window and I say that, oh, maybe this is good. If I use indices from 2 to 4, no, then maybe from 3 to 5, and so on. Those yellow sequences, they are infinitely long, like they are of size 1 billion, but you can jump to the next viable number. Only those n numbers from the input matter, so you don't need to go +1 if you don't get any new value there. So just those are the current sliding windows, they are on indices from 3 to 5, then just trying to find the closest next, maybe here in this the first yellow sequence, this is the next number that occurs in the input. In the second yellow sequence, it's here. Just take the closest of them and shift every sliding window to just include that. Consider, oh, maybe now, because now something changed, maybe now they contain together all the values from the input. That's one idea, and I think it's possible to continue this way, but I believe you can do better. If you get this to work, at the end you should get what complexity? Logarithm of the answer, so logarithm of 10 to 9th power, multiplied by n, and maybe multiplied by another logarithm of n, if you do some binary searches or sorting inside. Sorting of this you can do just once. So to find this next position, by how much you need to shift the sliding window to include something new, I think like you kind of also will move 6 sliding windows here maybe. But I believe this log of n can be avoided. That's possible solution, but not the best one. Instead, we can notice, we can just take a look at n number from the input, and we can say, well, this number must be done with one of 6 yellow sequences. I have 6 possibilities. Let's iterate over each of them. And then we know already something. We know roughly where my red sliding window is. Why is that? Maybe let's focus on 17. Let's say that 17 is first. Oh. And then there is 10. Okay. Take the first value, iterate over possibilities from which yellow sequence I take it, so on which string I play it, and one possibility is that I play it on the first one. The first one is a1 equal to 7, because 17 in that sequence is on position 10. What matters is the difference. Like here, 9 minus 7 is 2, which means 9 is on second position. So position is 10, position of this first value. Now I know that I will use an interval of indices, interval of positions, and that includes 10. If you imagine now some axis with that value 10, if you also use some other positions, the only important thing is what is the furthest thing to the left and to the right. Here it's those two. So thinking like that, you can eventually figure out that now, because you know that 10 is part of this interval being the answer, for every other value, like 10, 50, 12, you can just go through yellow sequences and figure out on which position you are there. Let's consider 50. Okay? 50, some other color, 50. In the first one would be on position 43, because we start with 7. And the second one, it would be on position 35. Let's say that third yellow sequence, it starts with A3 equal to 43 or 48. Okay, then it is something, 49, 50. Then 50 would get position 2. Here it would get position 41. Those are our possibilities. And actually among them, only 2 are we just need to consider 2 of them. Those closest to 10. And those are 35 and 2. 43 is only worse than 35. That's it for sure. Because I want my points to be close to value 10, because I know that 10 is part of the interval. If I get, in the optimal solution, I take position 43, which is, let's say, here. It doesn't make the answer worse to shift it closer to 10. So compute those 6 values, positions of 50 in each of yellow sequences, and just take those, the closest to 10 from left and from right. 10 and 35. So here, 2 and 35. If you do that for every value in the input, each of those n values, maybe also you'll get 8 and 20, you will also get 3 and 40, and so on and so on. And you get that just in complexity n times 6. No sorting needed, anything like that. Maybe you will need to sort 6 values. No, not even that. Among 6 values, you will need to take smallest among those bigger than 10 and biggest among those smaller than 10. So easy. In this complexity, you get those pairs. Also, the complexity is multiplied by 6, because my very first step is that I set at the very beginning in blue that I iterate over the very first number in the input, which string do you use for it. So it will go to which of yellow sequences. Only from that you get some position like 10 here. And you say, well, okay, 10 is part of this interval, so I want other points to be close to 10. So it's 6 for iterating separately over 6 possibilities. And then for every point you find its position in each sequence, you find among those 6 possible positions, you find those 2 closest to 10. By closest, I mean closest among smaller values and among bigger values than 10. Maybe one of them will be like minus infinity. And now the problem becomes, choose one value from each of those pairs to minimize the difference max minus min. Or in other words, there is axis, there is value 10, there are some pairs. Choose one point from every pair in order to say that everything needs to fit in a small interval. Like that. And this is a much easier problem to solve. I guess we will want to sort stuff. Yeah, we need to sort it. Actually, all those values occurring here, you can pre-compute all those n values just once, or like n times 6 values, compute them and already know their order. So I see some possible tricks to avoid here multiplying by logarithm, and to just say that there will be some pre-processing like this, multiplied by log for sort, and then it will be n times 6 squared times just nothing more. But let's just assume that this gets multiplied by logarithm. For sorting. This new problem is easier. We sort points from left to right. What do I do? Do I use sliding, some kind of 2 pointers? Maybe. I can, when I iterate, let's make this bigger. When I iterate over the start of interval, maybe let's say here, the interval will start, then I didn't take those red and yellow points, so I need to take them from here. So from this prefix of points that I skipped, I need to take both of them on the right. Yep, so just iterate over possible start, being one of those points on the left. Know what is the rightmost of points paired up with those I already left behind. So just maintain int max pair, max value paired up with those left behind. And for every point here, I don't know, x, consider pairing up x with this thing. So this minus that will give you length of interval. This is equivalent to 2 pointers. I used min heap. We can also use sliding window or 2 pointers, as you said. I think that's the easiest finish of this problem, where we just, after sorting, if we know what is paired up with what, so basically we just sort those beginnings, just sort pairs, like 8, okay, those from top right. Sort those pairs, then iterate over them, keep this, and whenever you have, for example, pair 2, 35, you consider 2 with already max pair you have, initially it's infinity, and then maximize this with 35, and then move on. Then it will be 3, 40, and so on and so on. Or you can use 2 pointers and just kind of imagine that you have some interval and you shift it to the right. When needed, you expand it, the right side, or when possible, you shrink the left side. You can call this find smallest subarray containing all indices problem. Yes. Can we just do that for the full problem? I overcomplicated, right? Yes, I think I did. For every, look, let's start a completely new solution, but it will be fast. This is the input array. For each value, I find its possible position in each of 6 yellow sequences. So let's say that for 17, its possible positions are 10, 8, something, something, something. I need to take one of them. Okay. Then from each of that I create a pair, 8, 1, 10, 1. Let's say also here we had 20, 20, 1. Then there is value 15, the input, and it also gives us some values, 40, something, something, maybe also 5, and so on. So this second value, it produces values 5, value 40, it's somewhere on the right, and so on. 40, 2. Okay, so I have those pairs, position, which number from the input it is, and with 2 pointers I can find the shortest interval containing at least one occurrence of every value. Maybe something like this will be good, maybe something like that, well, like this. We can use 2 pointers for that. And just to represent the inside of this interval, we will keep some frequency map, or just an array, and the number of zeros. Yeah. Int frequency of size n, also count zeros. That together allows you in constant time to add a new element and ask if all elements are, like, they exist at least once. Then I overcomplicated a lot. That's the full solution. That's it. Questions? Next stream will be on Tuesday, in 3 days. So very hard at coder problems. Next week, again, easy Codeforces problems. And we'll discuss on Discord server some homework stuff or deciding problems in advance before every stream. But it also has some drawback. Like, if I require you to already know something about the problem, then I will discuss solutions faster in less detail, but also those who do not know problem, everything will be too fast for them. It's good if everybody is on the same page. But I understand that if somebody really wants to train using my streams, they should have access to problems in advance. Otherwise, it's just hard to follow unless you're very good already. Yeah. Just thinking out loud. Okay, thank you everybody for watching. Yes, they are way hard. Because there are some people in the chat who like harder problems. I then keep solving harder problems. Well, I guess I wanted to aim with those streams to just beginners, like 1500 maybe difficulty, not 1800. This will always be a problem to choose proper target audience. Maybe half of a stream should be easier and half should be hard. The point of Tuesdays is to solve something very hard. Please solve impossible problems. That I'm doing on Tuesdays. Thank you for a wonderful suggestion. Yeah. Thank you everybody for watching. Join me on Discord server to discuss stuff. To also talk about this homework / choosing problems before a stream. Is upsolving useful? Yes, it is. Bye. Thank you for watching. Follow, not a follow, rate. My Twitch here is in dark. Coding game clash. That's a new game, a new guy doing coding game. Oh, that's for sure related to. I'm a coding game streamer. Cool. And now I'm done. See ya.